Hey y'all. I am going to start this video going over evidence of physical and chemical changes. Um, Sorry. What we're going to start with is starting with some vocab terms and then moving forward into physical and chemical changes. So you probably have seen the videos over elements and then compounds, and now we're moving into physical and chemical changes and like how would you know the difference between the two. What I highly recommend you do during this video is pull up your digital notebook and you'll go to slide 3, and when I start you can pause the video at any time, and then when you see things to fill in here, I recommend filling it in. And on the side too, you can just click and type. Yeah, all that stuff will be good for you to have and whatnot. But go ahead and make sure you kind of listen and, pause when you need to, rewind, replay, all that good stuff. So, where was I? Let me pull that back up. Okay, physical and chemical changes. Well, a big vocab term we're going to look at is a chemical reaction. So this is when these bonds between two or more molecules inside different compounds are broken down, and it creates essentially new ones. So you're making a whole new substance. Like you start with one or two things and you're creating something totally different. God bless me. Excuse me, sorry. Moving forward in the video, as you can see, this is in your digital notebook, these pictures. So underneath physical change, you'll copy these next notes, and underneath chemical change, you'll copy in these next notes. So we're going to start with physical changes. Now, a physical change is something that happens. It's a change that occurs, but it will just alter the appearance of something. It's going to change the appearance of a substance. It does not change that substance or thing into something new. An example, when you put eggs in a bowl and then you start to whip them, they're going to look way different, but it's still those eggs, okay? It has the same properties, really. We didn't create a whole new substance. It's still those eggs. It just looks a little different. Boiling water. In this picture here, it's still water. It might be a different temperature and whatnot, but it's still water. It's going to cool down, and it can be that same temperature water that you put it in the pot with eventually. Dissolving sugar. Many kids always think that this one is going to be a chemical change. And the reason why is sometimes your Kool-Aid drinks and stuff and little lemonades or Crystal Lights or whatever you put in water, many kids think that because that drink, you're using the water and like the sugar, and it's colored, it can change the color and make it look like a totally different drink. But if you were to let that water evaporate over time, that water will be gone, and then all of a sudden you're left with the sugar crystals at the bottom if you were to let it evaporate over time. And those sugar crystals will look a little different, but it's still those sugar crystals. So anytime you run into a mixing of a drink or something like that, it's going to be a physical change. Then we come to dicing a vegetable or onions or something, or even fruit, to be honest, like cutting up a banana. That's all going to be a physical change. You're changing the appearance of that thing, but you're not making a whole new substance. It just looks a little different. Another example would be like ripping paper or something like that. Okay, so no new substance is created. We're just going over really what a physical change is. Some of the key little aspects about physical changes are that you're going to have a change in the state of matter. Like it could be solid, liquid, gas, like water can do that. Change of color, similar to what I told you with regards to the mixing of the liquids with, not liquids, but the mixing of the Crystal Light drink or Kool-Aid pouch or whatever it is. You're going to have a change in temperature. Okay, so like boiling water, you can have a change in temperature. change the shape, like cutting up a banana or something. You're changing the shape, but it's still that banana. And then changing the texture, okay? You could have a piece of paper or like construction paper and crinkle it all up. It's not really smooth anymore. It's all bumpy and crazy, but it's still that construction paper. So I hope a physical change makes sense, and fill that in your notes. You can pause, go back, whatever you need to do. So now we're going to move into chemical changes. You'll see in your notes the area where it says chemical changes. And what we're really focusing on with a chemical change is going to be the evidence that you're going to look for, okay? But first and foremost, let's talk about what a chemical change is. A chemical change is going to happen when you have two or more substances and they're going to form a whole new substance, like something brand new with new properties. This is where a chemical reaction will occur from what we first talked about, like the first thing I mentioned in this video. Some examples will be iron rusting. You may even see a fence or like a piece of metal that you left outside or something, or like a bike can rust over time. Any metal can rust over time if not taken care of properly. But it's like this substance that just forms on top of that barbed wire or piece of iron or bike or whatever. It's a whole new substance that forms with new properties. Gas burning, that would be an example. You're going to have a whole new substance with new properties there. Eggs cooking. Once you cook the eggs, you're adding heat to it, and you really can't, it's going to turn into something different at that point. Similar to bread rising. In all honesty, guys, anytime you're cooking, it's going to be like cooking something on the stove or oven or whatever. It's honestly going to be a chemical change, okay? So like bread rising, and then, you can cook it in the oven and all that stuff. Yeah, chemical change. So here are some of the evidences. Now, in your notebook, when you fill in the evidences for a chemical change, you're going to put them here in each little, like each slide I go through, you're going to put it in these little tabs there. Okay, so the first one is an unexpected color change. Now, I did mention a color change for a physical change, but we know, like, if you buy red Kool-Aid, you know that that drink mix is red. You know those crystals are going to be color dyed red in there. It's obvious. So an unexpected color change is when you have new molecules created in a chemical reaction, and they really like radiate, glow light differently, producing new colors. Some easy examples. I don't really love the picture in the example here. That's more of a precipitate, like a whole new substance is forming in there. But honestly, same thing, I guess. So some really cool examples are fireworks and then leaves changing color, okay? You may not, an unexpected color change with the leaves, you're probably, you might not know that that tree down the road in the fall would change brown instead of like the pretty colors of green and yellow and like orange and all that stuff. So leaves changing color are definitely a chemical change. So an unexpected color change. Now we have the second piece of evidence, an unexpected temperature change. During these chemical reactions, energy is going to be released and is absorbed and into the surroundings, making it hotter or colder. Some examples of what we mean by this are adding baking soda to vinegar, and it's going to make that mixture, it's going to make that mixture's temperature decrease. It's going to get cold, okay? Your body temperature when it's fighting infections, it's going to increase. We know this because you run a fever. Your body's trying to heal itself. The third piece of evidence for a chemical change, if you're looking at one that you could look at, would be combustion, aka burning. This is when you're going to have a permanent change that can't be undone. You could give off heat and light. Some great examples of this are wood burning, like, you have a campfire going, that's a chemical change. A candle Now, when we talk about a candle, we've had discussions about this in the past, and kids have asked me, what do you mean by candle? Do you mean like the wax melting or the wick burning? So the chemical change for the candle would be the wick burning. We know this because you see the presence of smoke, heat, light, and I mean, you can see the evidence with the color change of the wick turning black. Now, the physical change part of a candle would be the wax melting, because that wax can cool off and it might look a little different, but that wax can then be heated up the next time and melted. So that part of it would be a physical. Then you have rusting, similar to when we said the iron rusting or a bike rusting, okay? Another example you could see would be like the word tarnishing. Silver can tarnish, and that's very similar to rusting, okay? I mentioned this a couple slides ago, but a precipitate can form. You could actually look at videos of this, and you could even see experiments of it yourself, but this is when a solid, honestly, suddenly appears in two liquids. And it's really weird and really cool at the same time. So anytime you have something that sours, like milk can sour if it's past, like, the date that, like you should drink it by. And really solid chunks form in it. So that's really gross, but it's a precipitate. And then sometimes, bathtub rings could happen if, you leave the water in there and you don't let it drain out. But I mean, but the best example I like is the milk souring. I think that's cool. All right. And then the last one here are bubbles forming. This is when bubbles are forming and they have gases that are released into the atmosphere. We know a chemical change is happening then. Cool examples out there would be like an Alka-Seltzer. You've probably seen commercials where they drop it in, the bubbles form. And then bubbles can also be released when you do vinegar and baking soda together, and you'd see the bubbles, and that would be evidence that you're looking at a chemical change, okay? Other than that, when you fill in your notes, it looks something similar to this. You'd just be typing it in, and you can type in whatever else you need on there too. But take a moment, make sure you filled in all your notes, and then that's it. I hope the video helped you.